Okay, question 10, astronomy, Big Bang. And it says, the Big Bang is one theory for the origin of the universe. And it suggests the universe had a beginning and the universe is still expanding. It says, which of these provide evidence that the universe had a beginning? So we're now after this idea. Well, we've got a photo of it, and that's the cosmic microwave background radiation. So discovery of other galaxies? No. Discovery of the moons? No. Discovering of planets? No. Discovering of the background radiation? D. Evidence the universe is still expanding comes from distant galaxies. Describe how light from these galaxies show that it's expanding. So we've said this idea, we've looked at Hubble's law, and this is the idea that the further the galaxies are away, the faster they're moving, so the more that their light is stretched away from us. And we use the example of say a fire truck or an ambulance. If it's moving towards us, the Doppler effect squashes the wave, so it goes higher pitched. As it's moving away from us, the waves are stretched out, it's got a lower pitch. So we're now going to this idea of redshift. They're moving faster, and the most distant ones are moving the fastest. So our universe is not only expanding, but it's expanding at an increasing rate, which is baffling and brilliant. Okay, so light from distant galaxies has been redshifted. Mark. This means that they've got longer wavelengths. So the light has a longer wavelength as it's been stretched. And the last part is this shows that the galaxies are moving away from us, and then it's at a faster rate the further they are. Now the question doesn't have that in for 2 marks, but the ones that are furthest away are moving the fastest. They're more redshift the further away you are. Okay, the steady state is also a theory. Give the difference, similarity and a difference between Big Bang and steady state. So there's the basic idea. They both start to say that the universe is created, but Big Bang is that everything started from a small central ridiculously hot point, and then it's expanding and cooling outwards with it getting faster and faster and faster. The steady state is that the universe is created, but as it expands, matter is made up in between those spaces. And again, the evidence is for Big Bang cosmology rather than steady state. So similarity, they both have an expanding universe. They both have a universe where more and more of the universe is expanding away from us. Fine. The difference, steady state has no beginning, and it just states that matter is continually forming in the universe. The Big Bang is the matter was all there at the start, and now it's actually being diluted over time. Next question, we've now got the distance from the Earth in megaparsecs and the velocity of the galaxies in kilometers per second. And we can see we've got a rough straight line of best fit there. You can see the points are scattered like mad. I could equally have drawn a line of best fit that goes here and here. Now, when we're dealing with such big distances, that makes a bit of a difference. So use Figure 15 to estimate the velocity of the galaxies at 15 megaparsecs. So we just read up at 15, read across. Each of those mini squares is 50, so that's 10,050. Next part, calculate the gradient. So we know that the gradient equals delta y over delta x. So there's delta y, there's delta x. So we're pretty happy here. We're after that gradient. Let's put our delta x down there. Well, we've had to use them. We know that delta x is 15, and we know that's 1050. So take the numbers you worked out, divide the one by the other. So gradient is change in y over change in x. 1050 divided by 15 is 70 kilometers per second per megaparsec. And then we'd have to write that unit. So you can see the 70 is no problem. But when we write it like this, our unit can be found from this. We've got kilometers per second on the top, there. We've got megaparsecs underneath, and that division there, we're just going to write there. And there you go. So a tricky unit to get. Hopefully that makes sense. Just write the units above and below, and that tells you what your unit is. The next one is the gradients of the line can be used to estimate the age of the universe. Explain why this is only an estimate, and we can just see, well, the data's scattered like mad. So there's loads of different lines of best fit I could have done, and therefore it's only an estimate. So the data points are scattered widely. So there are a range of gradients that could be drawn, or we can have loads of different lines of best fit would equally fit that data, so more data is needed. And there we go, end of the paper.